Good day, guys. Can you hear me?
Yes, sir.
Thank you.
Yes, sir.
Thank you very much, sir. What I've noticed is that umgosi uyatshisa mawuqala class. So I was wondering if uh ningasikhathi off manje saqala umgosi. Niboyivula nje mic niwuqede then niyivale. Anyway, last time we were talking about decimals, and I wanted us to finish the basics around decimals, and more importantly, performing some basic operations on decimals. So, why are we wasting time with these basics on decimals? Is because one, when we are actually dealing with proportions and ratios, you will find out that if you are not good at understanding how decimals work, how the multiplication of decimals work, and how the addition and subtraction of decimals work, then you actually start to face some challenges. And also, you will also notice that when we are actually dealing with equations and formulas, or we are dealing with calculating interest and let me just say finance, you will find out that you are actually having more challenges. And when we are moving to stats, somewhere along the line, you will actually face even more challenges. That is why we are spending more time on the decimals. I know that some of you are already bored, but just try and make sure that at least you you pay attention to what we are doing, so that you are not left behind. So today I want us by the end of today's lesson at least to say that we understand the multiplication of decimals, and also we understand the division of decimals. I will start with multiplication and then go to a division, and then I will go back to multiplication for the last time, and you will see why I need the multiplication again for the second time. So I also gave you some exercises so that at least you can understand how this multiplication is actually working. So we'll start with multiplication. I don't know why my multiplication of decimals. Don't know why my writing is like this. Last time I checked, my writing was a little bit cute, but now it seems like it's something that I can't recognize myself. But this is multiplication of decimals. So I gave you some task, and I said to you that evaluate or calculate the following. Let me write it as it is. I said evaluate the following. Usually we say that evaluate the following products, because when you are multiplying two numbers, two real numbers, what you actually end up getting is a product. So sometimes when someone is saying find the product, they are actually telling you that evaluate the multiplication. The same thing when you are taking a number and you're subtracting another number. So if let's say you have some number and you're subtracting another number, you know that what you are going to get is a difference. So someone might ask you evaluate the difference of these two numbers. They are actually talking about subtraction, and when they are saying that evaluate the following sums, they are actually talking about addition of two numbers or even more. And when they are saying evaluate the product, they are talking about multiplication of two numbers. And if they are saying to you evaluate the following quotients, they are actually telling you that they want you to evaluate the division of two numbers. I want you to know the notation that this one means the difference, this one means sum, this one actually means the product, and this one means the quotient. So at least you must know those basics so that you don't end up getting confused when you're asked these questions. So the homework was just saying that I gave you a question number A, who was saying evaluate 0.5 times 2. And then another one was saying I wanted you to evaluate 2.5 and then times 1.2, or 1.2, and then I wanted you to actually evaluate C was 0.3. Let me add. Yes, okay. Yeah, and then after that I said evaluate as 0.3 times 0.3, and then the fourth one was I wanted you to evaluate 6.25 times 0.4, and then from there I wanted you to evaluate the fifth one, which was 4.5 times 2.2, and then the last one was number F, and in number F we said that I wanted you to evaluate 5.542, and then you times this by 6.78. Those were the questions that I actually gave you under the multiplication of decimals. So I said just try and see how far can you actually go finding these multiplications. And of course, as I said last time, that there are different ways of actually solving these questions, but the one that I want us to follow is the standard one, except the fact that some of us are just not seeing the point that if you have 0.5 times 2, I'm just going to press in a calculator and see what I'm going to get. But that's one of the methods that you can use. But when we are doing these things, the reason we are following all these procedures, we want to make sure that you're getting used to actually solving mathematical problems and also following the rules of mathematics. And then at a later stage, when you're solving some of the problems, you will straightly just use a calculator. But when you're doing that, sometimes it becomes a challenge because you end up not realizing what do we mean by having this piece after the comma. So that's what we are trying to do when we're working with these examples. So the first question that I have is, did you do your homework? Yeah. Those are some of the challenges we face when we're actually having few classes per week. Maybe we need to have classes every day. Maybe we'll make sure that we're actually having a chance to do the homework, because we end up forgetting the homeworks when we are not doing when we are not attending classes every day. Maybe I'll request so that we can actually have classes from Monday to Friday, so that we won't end up forgetting homeworks. So the first thing that I want you to do when you're solving these problems, especially if you want to make sure that you don't lose marks if these questions are not multiple choice questions. So the first thing that I want you to actually do here, I want you to do this. So if you look at 0.5, I want you to convert this 0.5 to a fraction, right? So once you are actually converting this to a fraction and convert this to a fraction, you can multiply two fractions, and then after that you can simplify. So that's what I want you to do. So when it comes to this one here, when you want to convert it, the first thing that you want to actually do here is just say that 0 comma something. It means that the whole number is actually 0, so you have a whole number here which is 0, and then this number here is actually in the numerator, and then in the denominator you always end up with a 10, and then this you end up with a 1, and then you count how many numbers are after the comma and you find out it is 1. So it means that you are actually having a 0 there, or you are actually having 1 0 there, because you have one number after the comma. And then after that you multiply this by 2, and you know that 2 is just the same as 2 over 1, so it's not a big deal. 2 is the same as 2 over 1, or 5 is the same as 5 over 1, so you don't have to worry about that at all. And then after that you can say that for this one here you wanted to convert it to actually a fraction, not a mixed number. So you say 0 times 10, and you end up getting a 0, and then you say, okay, I have a 0, and then you add what is in the numerator, which is a 5, and then after that you divide by what is this number here, or you just take this number as it is. So that is why for the first part, you actually end up getting 0 times 10, which is 0, and then plus what is in the numerator, and then divide by this number here. And then the 2 we will leave as it is. We are not going to do anything there. And then we know that 0 plus 5 is the same as a 5. So that is what is nice about this whole thing. And also another thing that I want you to actually notice here is that if you ask yourself here how many 5s out of 5, you will actually end up finding that there is 1 5 out of 5. And when you're asking yourself how many 5s out of 10, you will actually find out that there are 2 of them, and then you still multiply by a 2 over a 1. And you can see that I have a 2 in the numerator. Or if you don't want to do, you multiply this number with that number, and you end up getting 1 times 2 is going to be a 2, and then in the denominator you multiply 2 times 1 and you get a 2, which is the same as how many 2 out of 2 is 1, and how many 2's out of 2, or you can just say 2 divided by 2, you know that it is a 1. So that is the procedure that I want you to actually end up following. Take this number, convert it to a mixed number, and then take this number, convert it to a mixed number, and then after that you can convert it to fractions, and then you can multiply fractions, because I know that you know how to multiply fractions. And then from multiplication of functions you will actually realize that this is the number that you're getting, and you're actually getting a 1 here. Another thing that I want you to actually realize here is that if you can actually see what is actually happening here when we're asking how many 2's out of 2 and how many 2's out of 2, you are getting a 1 and a 1. That understanding is actually going to help you when you're actually dealing with ratios and proportions. And also another thing that will be much more important when you're dealing with these things, once you understand what is a decimal, you can see the relationship between a decimal and a mixed number, and from a mixed number to a fraction, then you will be able to understand the meaning of a percentage, because we will actually end up doing percentages. Because when someone is saying your money is growing in a bank or in a financial institution like Old Mutual or Sanlam, we usually say that we will give you this amount of interest so that your money is actually growing. And also another thing, when you decide at a later stage that you want to buy a house or you want to buy a car, you will find out that the bond is usually or these installments, they are usually represented in percentage. So I want you to make sure that you understand these decimals. And then for this one here, all you have to do, I want you to realize that the number before the comma is actually the whole number for this particular number here, and then the number after the comma is actually giving you a fraction out of a base of 10. So what this thing is actually meaning, it just means that you have a 2 as a whole number, and then in the numerator you take this number as it is, you have a 5, and then after that you divide by 1 and some zeros here. How many zeros you supposed to have? I have one number here, so I will have 1 0 here, and then I want to multiply by this number here, so I put some brackets around to say that I wanted to write something that only belongs to this, and this dot here, I am actually trying to tell you that there is multiplication there. I don't want you to be confused and say we ended up having so many dots. That's actually the multiplication that I'm talking about. Of course, some people prefer to use a dot because I don't want to confuse you. Let's use multiplication as it is, like that. Some others, they use a star, something like that. It's just one of the things, mathematical things, but let's just use this one for us, the standard one. So once we have this hello?
We couldn't see the screen.
Are you seeing it now?
Yes, sir.
Okay, thank you very much. So how many of you are actually logging in with one device? Okay, let's leave it like that. Okay, now that you are having this, another thing, guys, that I want you to notice here is that sometimes when the network is slow, you will end up not seeing the screen. And also another reason why I am not adding my camera here to see my face is because once I add a camera, you're not gonna even see a screen, and not only that, my voice will be lagging and you can't properly hear what I'm saying. So that is what usually happens. So when I'm sharing only a screen, at least you can see something. So when it comes to this one here, the number that is before this dot here or this decimal point is actually the whole number. So you place the whole number as it is. If you had a 10 before the decimal point, you were going to place a 10. If you have 100, you were going to place 100, and then after that you have a numerator and the denominator. So here, the number that is after the comma, you take it as it is as your numerator, and then the denominator, we will end up having a 1, and then that 1 there that you are actually having must be accompanied by the number of zeros. So here, how many numbers do you have after the comma? You have 1, which means now we're supposed to divide by 1 accompanied by 1 0. So that is actually what you are actually getting there. And then from there, you change this to a fraction by taking the whole number, multiply it by a denominator, and then you will end up getting 2 times 10. We know that it is going to be a 20, and then you add the numerator, which is a 5, and then you divide this whole thing by the same denominator that you had there. And then after that, you actually end up simplifying this. You say 1 times 10, you get a 10, so we'll end up having a 10, and then you add the numerator, which is a 2, and then you divide this whole thing by a 10. And then after you have done that, you will actually find out that what is happening. You are actually saying, okay, 20 plus 5, that is actually 25. That is actually 25, and then here you will actually end up having the 10 as it is, and then this one here, you know that 10 plus 2 is just a 12, and then you divide this whole thing. Let's use a multiply instead of a dot because I don't want you to confuse this with that. And then after that, you divide by a 10. The next thing that you will want to actually do here is actually you want to end up simplifying this whole thing here. I am going to push this thing a little bit down, and then after that I am going to write what needs to be written here. and then you are looking for the common factor here. It's easy to actually look for common factors, and you will actually realize that this one here is a 25, and this one here is a 10, and this one is a 12, and this one is a 10. So what is the simplest way of actually finding out the common, the highest common factor here? You look at the number between the numerator and the denominator, the one that is smaller than the other. So you look at 10, you ask yourself, what are the factors of this 10 here? You'll find out that 1 is part of them, and then you find out that 2 is part of them. And if you are dividing 10 by 3, you will find out that you are getting a remainder. So 3 is not the factor of 10. And then you go to 4, you ask, if I divide 10 by 4, will I not end up getting a remainder? So you find out you have 4, you have 8, and then there's a remainder 2. So 4 does not go here. And then you actually ask yourself, how many, is it possible for us to actually divide 10 by 5? And you find out that you have 5 10, so 5 is also one of the factors that are actually dividing a 10. And then you go to 6, you find out that 6 cannot divide 10, 7 cannot divide 10, 8 cannot divide 10, 9 cannot divide 10, but 10 can actually divide 10, and you end up not having a remainder. After you have found these factors of this smallest number that you are actually having here, you ask yourself, can I divide 12 with 10? This 12 over here, you will find out that we can actually not divide 12 by 10, because I will have 10 and then I have a remainder of 2. So 10 cannot be actually a factor of 12. And then you ask yourself, can I actually divide 12 by 5? Right. So when you are actually dividing 12 by 5, you find out that we are actually having 5, 10, and there's a remainder 2. So 5 cannot actually go to 12. So you actually exclude it, and then you go to 2. You ask yourself, can I divide 12 by 2? And then you find out actually we can divide 12 by a 2. And then all you need to do here, you just ask yourself, for this one here, we have this. How many 2's out of 12? You find out actually there are 6 2's. And then how many 2's out of 10? You find out actually there are 5 of them. And then you do the same thing for this one here. You ask yourself, can I divide 25 by 10? You find out actually we will end up having 10, 20, and then we have a remainder 5. So 10 cannot actually go to 25. And then we started to ask, can we divide 25 by 5? And we ask how many 5 are actually in 25. You find out actually there are 5 5s, because you have 5, 10, 15, 20, 25. And then after that, you actually ask yourself, how many 5s are actually contained in 10? You find out actually there are 2. And then next thing that I want you to realize that is that if I have 5 over 2 times this, I want you to also realize that this is the same as I can switch these things in the numerator around, is fine, or these things in the denominator around is fine, as long as I have a multiplication there. That is what I want you to realize. But either way, we're not going to do that so that I don't confuse you. We have this 5 times 6 here, which is just 5, 10, 15, 20, 25, 30. So you actually having a 30 there. And then you actually end up having 2 times 5, which is actually a 10. So how many 10s out of 30? You can see that 10s out of 30, we are actually having 10, 20, 30. So we're actually having 3. So the answer to this is just a 3. Or you can say 2.5, and then you multiply this by 1.2. What is the answer? The answer is supposed to give you this 3. That is what is important here, because every time you know what to do, you are getting a mark. Every time you know what you are doing, you are getting a mark. Every time you know what you are doing, you actually get a mark. And then of course you will get a mark for the simplification and also the final answer. So that is actually what we are doing in this particular example. But for those of you who wanted to cheat the process, because Akona, please. Yeah, so for those of you who are actually trying to cheat the process, there is actually the way for those who like to cheat the process. So what you can actually do here, at least for this one, you can see what is basically happening. That what you do, you take this and you place it as it is, and then you take this and you place it as it is in the numerator, and then you divide. You ask yourself how many numbers are after the comma. Find out there is 1, and then you can say that, okay, I will have 1, and then I will have 1 0 there, and then you do the same thing here. And then from here to here, you can say I am going to actually jump this process. If you are using a Casio calculator, this is simple, because you can just say I want to change this. If you look at this here, at this thing, you have a fraction here that is actually represented. So what you actually do here, you can just say I am going to shift here. Let me first place an on here. I'm going to shift here. I am going to place this. You can see that now this is actually the whole number, this is a numerator and this is a denominator. So there you can place a 2, and then you go here and place this to say you're going to next, or go down, or go up, or go to the left. And then the numerator, you know that it is 5, and then the denominator, you know that it is 10. So the calculator here, you can just press equal. It's going to change this thing for you. And if you can see here, you can jump from this step and also go to this one here, and then you can do the same thing here and end up getting this nice step here, and then you will have a mark for actually this simplification up to this far, and then you can multiply this by 2, and then you get these things. So don't be so afraid to use a calculator, but you must have a system of actually using a calculator so that you don't end up losing marks unnecessarily. Let me try and do this problem and see if we can actually end up getting a nice and straightforward answer. For this one here, we are having 0,3, which means the whole number is 3. The numerator is, the whole number is 0 because it's 0 before the decimal point, and then after the decimal point you are having a 3 there, and then from there you can say that how many numbers that are actually after the comma. You find out that there is 1, so I have 1 0 here accompanied by 1. I'm done with this one, and then I'm multiplying by this one here. You can see that this is the same as that, so I'll just say I have a 0 number, I have 3 in the numerator, and then I have a 10 there. So once you are having something nice like this, all you need to do, you need to convert this to what it's supposed to be. So what I'm actually saying here, you multiply 0 by 10, and then you will end up saying 10 times 0, we know that is a 0, and then you add what is in the numerator, and then you divide by the denominator as it is, and then you're gonna multiply this whole thing by, because this one is having this whole number, 10 times 0, we know that it is 0, and then you add a 3, and then you divide by the denominator as it is. 0 plus 3, you know that it is 3 over 10, and then 0 plus 3, you know that it is 3, and then you still have a 10. Of course, you can see here that you are actually having 3 times 3, you are actually having a 9 there, and then here you have 10 times 10. For 10 times 10, you need a calculator, but if you are good with the square of numbers, you know that 10 times 10 is just a 100 here. You add a 0. And then actually, once you are actually having this whole thing here, because we were given this in a decimal form, so we want it back in a decimal form. So here you ask yourself how many 100 are in 9, and then once you ask yourself, you find out there's 0 of hundreds out of 9, and then after you have done that, you know that there is no whole number, so you want to isolate that whole number by a decimal point. And then after that, you add a 0 here, and then you ask yourself how many 100 are actually contained in 90, and then you find out actually there are no 100 in 90. So what you actually end up doing here, you say there are 100 contained in 90, and then when you are adding this 0 there, you add another 0 there, and then you ask yourself how many 100 are actually contained in 900. You find out that actually we have 9 of these 100 there, and there is no remainder. So this is actually what we were looking for here, because 0.3 times 0.3 is supposed to give you something interesting like 0.09. So you get your full marks by knowing this and that, and then this, and then you work it out, and then you get that. And then of course we actually ended up having our D. Where did our D go? I think it just disappeared. I will try and add it here. So we had our D here, which was we had a D, and then we had 6 times 25, and then multiply by 0.84. And then of course we said that the first thing that you need to do here is very straightforward. You take this number as it is, right? And then once you take this number before, yes.
Pilwentle raised her hand.
Oh, okay. Sorry. Pilwentle, what were you asking?
Yeah, it's a me. Like, I'm going to go. But I said, someone to some word, but come to go. And a lot of that command of go. Right, and yeah, the problem comes out on that all.
Guys, are we having the same problem?
No,
Yes, sir.
no,
No,
sir.
Yeah, I think the problem is just the network. If the network is good, you're supposed to actually not experience that. But the good thing is that if you happen to miss that part, I will record the lesson. You can just go straight to that. Is that okay?
Yes, sir.
Yeah, that's what I'm going to do so that you don't end up missing out. Yeah. And also another thing, as of next week, you will find out that I will be there in the office. So if there is something you did not understand, you can go there, and I will be able to assist you. If you find out that you can't get to me, you know that we do have people who are assisting, and they are happy to assist you too. They will never chase you out and say that, no, this was done in class. They are happy to do that. So you can always find help if you're still not getting it. But I will record the lesson just in case. So let's try and focus on this D. So in D, we wanted to actually solve this. And now when we are solving this, again, I said that the number before the decimal point is the whole number. So you isolate it, and then you place a line that is saying that I want the numerator and the denominator. And then after that, the number after the decimal point is what you place in the numerator. Just like that. And then after that, you ask yourself how many numbers are after the decimal point. So there are 1, 2, there are 2. So I'm going to place 2 zeros accompanied by a 1. So that is what this thing is actually all about. And then you multiply this whole thing. And then for this one here, the whole number is 0. So you have a 0 there. And then after that, you know that I want the numerator. The numerator, you take it as it is. So you have a 4. And then in the denominator there, you ask yourself how many numbers are after the comma. So there is only 1, which means there is a 0 and a 1. So that is actually what you do. The next thing is you want to convert this mixed number to a fraction. So 6 times 100, that's what you actually ask yourself. Oh, 6 times 100. If you don't know, you have to be honest with yourself that I don't know 6 times 100. You have a calculator. 6 times 100 is going to give you an answer. But of course, 6 times 100, we know that it is actually 600. And then I wanted to add a 25 from it, which is the numerator. And then you divide by the same denominator that you had. Right. Once you actually have this, you multiply this whole thing by this number here, but in a fractional form. So we have 0 times 10. You know that it is supposed to be 0 plus the numerator as it is, and then you divide this by a 10. So that is how you are actually doing this whole thing. And then 600 plus a 25, that was a 600, and then you add a 25. So you have a 600 here. No. You have a 600, and then you want to add a 25. So this is 600, 0 if there is nothing after the comma. And then I want to add 25 or 25, 0. So you first place the comma there, and then you have a 0, and then you have a 5 and a 2. So you want to add a 25. Of course, here there is nothing. So if there is nothing, I place a 0. And then here 0 plus 0 is just a 0 and a dot. 5 plus 0 is just a 5. 2 plus 0 plus 2 is just a 2. And then 6 plus a 0 is just a 6. So you are actually having here a 625 or a 625 like this. So that is actually what is important here. So we are actually having 625, and then you divide this whole thing by 100, not 1,000. Why am I writing wrong things? And then this one here, you know that 0 plus 4 is just a 4, and then you divide by 10. Of course, the next thing that you need to do here is to write the factors of the smallest number between these two numbers. Which number is smaller? Is it 100 or is it actually 625? So 100 is smaller. So when you are having 100 as the smallest number, what you need to do here, you need to write the factors of 100. So you know that factors of 100 are very simple. 100 is one of them, and then 99 cannot be. And then any number, I'm just gonna try and simplify this, because if you are having 80, I mean you get 8 and then the remainder is 20. And then if getting 70 is going to have go to 100, but you will have a remainder of 30. 60 is going to do the same thing, but when we start to arrive at 50, that's when actually we are getting one of the factors of 100. And then from 50, you know that if you go, you have a 40 or 40 something is not going to go to 100 without having a remainder. For instance, 45 plus 45, you know that that's a 90. So we'll have a remainder of a 10. So 45 cannot go there. And also if you go to 40 to 80, and then we have a remainder 20. So anything up to 40, we're not gonna get anything. And when we are going to actually 30, still is going to be the same thing. So you can go to 25, and then from 25 you can go to 20, and from 20 you can actually go to actually 10, and then from 10 you can go to 5, and then from 5 you can go to, what am I doing here? There are some numbers that I think I've jumped. This one is that, and then this one is a 4, and then you have a 2, and then you have a 1. So what you next do, you ask yourself how many hundreds, or can 100 go to 625 without leaving a remainder? We'll have 100, 200, 300, 400, 500, 600, and we'll have a remainder of 25. So this one cannot go. And then if you go to 50, for 50, of course, 25 will be the remainder, so 50 cannot go. And then we start asking about 25. So how many 25s are we actually having in 625? One thing for sure, in 100, so if I have only 100, so we know that in 100 we have 25, 50, 75, and actually 100. So here we are having 4 25, and then in another 100 we are also having another 4 25s, and then in another 100 you are actually having another 4. And how many hundreds are actually contained in 600? We're actually having 6 of them. So we have 1 2 3 4 5 6. So we'll end up having 4, and here 4, and here 4, and the last one is going to be 25, and here we have 1. So 4 plus 4, we know that is a 8, and then you have a 12, you have a 16, and then you have a 20, and then we have a 24, and then we have a 25. So here 24 625 divided by 25 is just a 25. And then here, how many 25 are we actually having? You will find out that we are having 4 of them, and then multiply by, we are having a 4 divided by a 10. And then one thing for sure is this thing, as I said, if you wanted to work it out, there are several ways to do it. One way to do it is to cancel this 4 and that 4, and then this thing is gone. You end up getting a 25 over 10, and that's it. But if you are following our system is very consistent. It's saying that multiply these two things. 25 times 4, you know that is just 100, and then you say 4 times 10 is just a 40, and then after that you ask the common factor between these two, and you know that 10 is the common factor. You ask how many 10s are there, you find out actually I'm actually having 10 there, 10 tens in 100, and then you ask yourself how many 10s are contained there, and you'll find out that there are actually 4. And of course you can also reduce this and ask yourself how many 2s are here, and then you find out there are 5, and then how many 2s are here, and you find out that there are actually 2. Then finally you convert this to a decimal place, because we are actually having decimal points there. So this one, you ask yourself how many 2s out of 5. You find out there are 2 2s out of 5, but there will be a remainder of 1, and then you place a comma here because you want to separate this whole number, and then you ask yourself how many 2s are actually contained in 10, and then you find out there are 5 of them. So that is actually what is actually important in this particular case. So this is supposed to be the same as 2,5. That is what is important. Or you can say 6,25 times 0,4 and see what you are getting. Of course you are getting a 2,5. So this is the process. Let us try now and solve this one. This one is straightforward. I want you to do it. I will give you 3 minutes and send it on WhatsApp. Try and do this one and send it on WhatsApp and see if you are actually getting what we are actually doing. Number E. You try and do it. I'm gonna give you 3 minutes. I'll give you all 3 minutes so that you can finish this. When you are done, just send it here on WhatsApp. We are doing number E. Try and do number E and then see what you are actually getting, and send me all the steps on WhatsApp. it's hard for me to open view once with a computer. Please try and remove that as possible. So we are having this one, you change it to a 4. Let me view it. This one you actually changed it to a 4. This whole number here is here, and then this 5 is there. How many numbers? This one is correct. And then this one you have a 2, and then this 2 is there and you have a 2. That is actually correct. 4 times 10, that's a 40, plus 5, which is a 45, and then you still have a 10. And then this one is a 20 plus 2, which is a 2, and then you divide by 10. And then of course you're having this. Yeah, one step is missing. How did you end up here? There's that step that is missing. I want it. Lee, please add that step. I want to see it. That's the only step that is missing. But either way, one thing that I can say here, from here, we can say that you ask yourself how many are 5s contained in 45, and there are 9 of them. And how many 5s are contained here? There are 2. So you will end up having a 9 over a 2. And then this side here, you will also gonna have how many 2s contained in 22, and then you'll find out there are 11s of them, and then how many 2s, and then you'll end up having a 5, and then you can multiply nicely, and then you will end up with something that 2 steps missing, so that you will end up getting here. But at least you are getting the point. That is what is important here. So that is what is important. So I'm just gonna follow what Lee was doing. I'm not gonna do my own thing. Lee actually led the way. Okay, we have Lee here, and then we're actually having Asive. This one times that, you have 900 and 100, then you divided that, you have 9.1. Asive, I think what you are doing is fine here, because you will have 100, and then you will have this. What Asive did is actually correct. And then who else did this? Aluta Momoza, let me see. Still, this one is also correct, because you simplified further. What Momoza did is correct. Let's look at Jevu. You have 9, you have 11 over 5. Of course, when you're taking this times that, you're getting that over 10. And then, okay, Jevu, this is correct. Naomi, what were you doing here? Let me see. Oh, it is fine. What you're doing is fine. Let me look at Rose. Rose, this is correct. And then we are having Boshle, this is correct. Mihleza, this is correct. Okay, this one actually you all did it correct, so there is no need for me to actually proceed with that. What you did is actually correct. Try number F. I will give you 3 minutes. And also Love and Some Flowers is actually did something that is actually correct here. We can see that we have Love in this class.
So is it 542? I can't see the number here.
This number?
Yes.
Okay, this is actually, let me try and write it to be bigger. It's 5, 2. This is a decimal point, and then you have 5, 4, 2. Can you see it now?
Yes, sir.
Okay, thank you. So try and do this this question and see what you're getting. And then we have Love in this class. Mihle rest. I think it's grand in faith. You know, what you're doing is actually fine here. Yeah, let's try, guys, and do number F. You know this thing. You know this thing. Asive, you have wrote something. You have 37.57. Where's the rest? Let me look into this. Okay, I will start with Asive. The first step, which is 5 4, okay, 5, the one number is 5, and then you have 542 divided by 100. The first step that you did is correct, and then we go to the second step. I am convinced that is correct, and then this that step is correct. Okay, the second step and the third steps, they are correct, and then we go to the third step. The third step is still fine. I don't know what happened, because the answer you are supposed to end up having is this here. Let me go back here. I'll make it this straightforward. You're supposed to end up having, you had 5.542, and then you multiply that by 6.78. So the answer you were supposed to end up having is this. So the only thing that really happened here, there is that part that is Braille. I don't know what you did there, Asive, because that's where I think everything went wrong, because the final answer was supposed to be 37.57476. That was supposed to be the correct answer. Naomi, what you actually did is we are having 5-4. That one is correct. Second step, 78. Let me see. Okay, I see what is happening with Asive. The only thing that you did is this one here. You had a 5 there. So that is why you are having this 7.41. That is why you are having this. My writing is bad. You did not actually make a mistake. Maybe it's my writing. This one here, you took it as 5. You made a 5 here. So what you did is actually correct. So if I was marking your steps there, I was going to deduct 0.5 of a mark. And if this question is out of 5 marks, we're going to get 4.5, which is, if I'm rounding it off, it's still 5 marks. So everything you did is correct, except that this one you recorded as 6.75, right? And then let me come here and make this like this. So this one here, that's the mistake for Asive. You have this 5 here, it was a 8, but everything is correct. If this one was correct, your answer was going to be correct. Naomi, what we are having for Naomi is this. He multiplied this and then added that. This is correct. This one, and then he added that, and then this is correct. And then after that, he divided, and then he got that, and after that, he divided, and then he actually got it. So this one also is correct. Naomi, what you did is correct. And then let's go to Rose. Rose, you have this one is also, this one is 100% correct. And then Aluta Momoza, what did you do? We have this, we have that, we have this one and that, you have this and that and that. Oh, this one is also correct. And then let's go to this one here. You have this, you have that, that's a mark. And then this one and that, that's a mark. This one and that. This one is also correct by Lulu Tojevu. Let's look at this one here. Mihleza, what did you do here? Oh, this one is also fine. We have 7, 4, 6. Okay, this one is fine. And then Molly, we have this one, we have that and that. You have this one and that and have that. This one is also fine. And then Bohle, what did you do, Madam? This one is this. You have this one and then okay, this one is all. What is going on there? Okay, this one is also fine. So I think we're actually good with this. We actually understood what we are doing here. We ended up with Bohle. And let's look at some love and some flowers there. What are the flowers doing? Let's actually see here. So this one is kind of looking different. We have this one. Something is missing here. There is something that is missing here. You have a 5. Okay, this is the 5. 5 with this one, with that, with 7, 8. And then we have this one here. I also think this one is also correct. And then let's look at the others here. I think that is all. Okay, let's move now. Let's move to the division. I think all of you are actually getting this question. So what we're actually gonna end up doing now is the division of decimals, right? So how do we actually divide decimal numbers? I think all of us are actually getting this. So there's no need for me to actually give you corrections because I can see all of you are actually getting this, except for Asive, but the answer is still correct except that she wrote a 5 instead of an 8, but still fine. So let's go to the division of decimals and see what can we actually do when we are dividing decimals here. So if let's say you wanted to divide this number by that number, there is only one thing that I want you to always do, right? The first thing that I want you to do, you do the same thing we're actually doing with the same thing that we're actually doing with the multiplication. So what you actually end up doing here is that you convert the first number and then you put it inside the brackets, and then of course this one is a 1, is a whole number, and then this number before the comma here is a whole number, and then you create a numerator and the denominator. The number after the comma is the one that goes to the numerator, and then you also ask the same thing, that how many numbers after the comma. You can say that, okay, I have one number there, so I will end up having a 10 there. But guess what happens here is that if I'm multiplying this thing by 10, I will get a 10 and then plus 0, so I will get a 10 over 10. Yes. So basically for this one we have that. Even if let's say you were saying I have 1 divided by 2, I want you to know that 1 is still the same as 1, 0 or 1, 0, 0, 0 is still fine. And then for this one you multiply, 2 is the same as 2.0. Of course, the whole number here is a 2, and in the numerator you know that you're having a 0, of course. And then how many numbers after the comma? We have 1, so we have 1, 0 and 1, 1 there. Of course, this thing is very nice because you really know what is actually happening here, because 1 times 10 is just a 10, and then 10 plus 0, you have a nice 0 there. And that this one is not a multiply because it's a divide, so it's a divide. Sorry for the confusion. We're just converting this and that. So that is what is happening. We haven't done anything here. And then the next thing that you actually need to do here is that you take this denominator as it is. So you have a 10 there. And then you still have a divide there, a nice divide. And then here you have 2 times 10. You know that it is actually a 20. 20 plus a 0, which is the numerator there. And then you divide by the denominator, which was a 10. And then from there you can see that 10 plus 0 is just a 10, and 20 plus plus 0 is just a 20. That is what is nice about this whole thing there. And then the next thing that you are going to do now is this. I want you to change this this division to multiplication. So when you are changing the division into multiplication, you keep the first fraction as it is, and then you change it to multiplication. So when you are changing the division to multiplication, you interchange the denominator, so the denominator will go up and then the numerator will go down. So what was the denominator was going to be a 10, and what was a numerator was a 20. So when you are looking into this, you will find out that actually I'm just actually having 10 times 10. You know now that we're actually having a nice 100. And then of course here you actually ask yourself, what is 10 times 20? And 10 times 20 is very simple. You can even use a calculator if you don't know. And then of course I will tell you straightforward that it is actually a 200, of course, here. So once you are having this nice thing here, you ask yourself how many 200 are contained in 100. You find out you can't end up having a 200 in 100. So there are 0 of them. So the only whole number we can get out of this is 0. So you place a comma, and then that decimal point that you're actually having, it means that we start to add a 0 there. And then you start asking yourself how many 200 are in 1000. You find out you have 200. You have 400, you have 600, you have 800, and then you have 1000. So you are actually having a 5 there. So we have 0,5, and there's no remainder. So what is basically important about this whole thing is this one thing, that as much as I did this whole thing, I could have just done this from the get-go and say that this is the same as 1 over 2. And of course, how many 1s are out of 2? We have 0 of them. I add a 0. I place a dot there. How many 2s out of 10? We have a 0,5. I just wanted to show you how this method is working with something that you already know. Let us actually end up doing this. I am going to do B and C, and then I want you to do number D, and I want you to only do number D. Okay. Let me do this. I want you to do number C and number D, and then send the answer on WhatsApp. I'm just going to do this one, and then you do number C and number D, and then we can call it a day. I'll just explain a few things here, and then we call it a day. So here, what is happening, I said that the first thing that you need to do, change this to a mixed number. To change this to a mixed number, you must realize the number before the decimal point is a whole number, and then you change the numerator and the denominator. So what is in the numerator is what is after the decimal, so it's a 6. And then after that, you ask how many numbers are after the comma, so you're actually having 1, which means we're having 1 0, so you have a 10. And then after that, remember that we're still having a divide there, and then we convert this one to a mixed number. The whole number is a 1, and then what is in the numerator, you know that it is a 2. And then from there, you ask yourself how many numbers are after the decimal point. There is only one number there, so there is only 1 0 in the denominator and a 1. And then after that, you want to convert these to fractions. Of course, if you want to convert this, is 3 times 10. You know that's supposed to be a 30, and then you add the numerator, which is a 6, and then you divide by a 10, and then you divide this whole thing by you have 1 times 10, you know that is a 10, and then you add a 2, so you have a plus a 2, and then you divide by what was there. And then the next thing that you need to do, you must realize that 30 plus 6 is just a 36 over a 10. And then of course I have a divide there, and then 10 plus 2, we know that is a 12, and then 10 is still nicely sitting there. The next thing that I want you to actually do here, I hope you can see what is basically happening here. So basically what is happening is this. I want to end up changing this part here, because this is a division. I want to use multiplication because I'm good with multiplication, so I want to change this. Whenever you are changing this, change the numerator and the denominator, so you end up having a 36 divided by 10, and then times, then you change this to go up, so you are having a 10 and then you're dividing by a 12. That is what is important here. So what I was saying here is that this whole thing here is the same as 36 divided by a 12 times 10 divided by a 10. I hope you can see what I did. I just switched the denominator because there is multiplication, there is no problem there. And also the same thing that I also want you to realize is that this whole thing is also the same as 10 divided by 10 times 36 over 12. So switching the numerators or switching the denominator, if there is a multiplication there is no problem. This is still the same as that. So once you are having this, you can see that 10 divided by 10 is just a 1. So how many 10s out of here? There are 1. Or I can just remove 1 0 here and 1 0 there, and I'm sorted. 1 over 1 is just a 1. Of course, that is what is important here. So what I want you to actually realize, I want to realize that all these things are just saying that I can cancel this 10 and that 10, and I'll be left with 36 divided by a 12. And then after that, you can say that, okay, there is a common factor there. And when you're looking for a common factor, find the factors of the smallest number. Factors of 12 is 1, 2, and 3 is also going, 4 is also going, 6 is also going, and we're actually having a 12. So when we are starting with the factors, we are looking for the highest. So start with the higher common factor of the smaller number. So how many 12s are in 36? Let's see if the 12 is going to 36. We have 12, and then after 12 we have 24. After 24 we have 36. So actually 12 is going there a couple of times. If you don't know the multiples of 12, all you need to do, you can just say I have a 12 first, and then I want to add another 12, so I have a 24. From 24 I have a 36, which is there. And how many of these 12? There are actually 3 of them, and here I have a 1, which means this whole thing, 3 divided by 1 is just a 3. So what we were counting here was just a 3. Can you try and do this one and that one, and then send me the final answers and see if we're actually doing the same thing? I'm gonna give you 5 minutes, and then I will explain what is happening down there, and then after that we can call it a day, and in our next class we'll just take a look at what is happening down there, and then we can move to some other things that are much more important. There are certain things that are important when it comes to the decimals, fractions and stuff. For instance, when it comes to proportions, ratios, the percentages, and all other things that are actually coming up. So I want you to make sure that you get comfortable with these things, so that when we are moving to other things, then you are much more you have some confidence that you actually know this maths, and you are not going to struggle when you're doing stats as we are going with our courses. Try and do this and see if we're getting the answer there. Okay, we have Mihleza, and we wanted to see if we're actually getting the same answer. What is happening here? This one you changed it nicely. Okay. This is a me problem now. We are actually having this one here, which is a 25. Of course, this is a 25. Okay. What is happening here? This is a 25. Oh, I wanted to write a 25, but that is fine. Let me look at this answer if this one is correct. Okay, Mihleza, the first step here is fine because this one is that and that one is that, and then this one here after that is actually this one here. We have 600, which is that, and plus 25 divided by 100. This one is fine. And then let's come to this one. We have 25 added 100 here times 100. You're trying to cheat me. It's okay, it's fine. So this one is actually 100, so it's going to be 2500 plus a 0, so it's 2500. And then you can switch these two around, and then you have this one here. 100 and 100 will cancel out, and then you are having that, so it's 25. So you said 25500, okay, and then this one you ended up saying 250,000. This one, let me see here. Here we are having 100. And then you are multiplying it by 2500, which is what you got there. It's supposed to be 250. Mihleza, can you see that here there's supposed to be an extra 0? There must be a 0 somewhere here. Oh, it's here. Okay, 250. Okay, it's fine. And then we have this 0 and that 0 cancels out, and then we have 625, and then you have that is 0 0 there, then you have that 250,000. Okay, what you did, Mihleza, is fine. There is no problem there. Where's the rest? Mihleza is actually correct here. Guys, we want to make sure that we leave. Your answer is correct. It's 100% correct. So there's nothing to fix there. There is kind of I was hesitant with this, and this one is there, and then you divide it, and then you divide by 1, and then you multiply it, and then you got that, which is what this is 1/4. You can also convert this to 1/4. Mihle rest, I think this one is this one you can convert it to, but it's still fine. So what you did is fine. Mihle rest is actually doing something that is fine here, and also Mihleza is fine. Naomi, you are dealing with number D. You changed this to that, and then you ended up having that, and then this one is 0.9 over that, which is 9. Then after that, I'll switch, these two will cancel out, and then you have a 9. So this one is actually fine. From Naomi, this one is fine. There's nothing to actually fix there. It's supposed to be a 9, of course. Who else came up with another answer? Okay, Ritabile. This is also fine because this one is 8 with this, and then you change it. You have that, you change it, this and that cancels out. Oh, you do not cancel, you multiply it instead. So you have that, and then divide by 100, and then 81, and that. This one is fine, Ritabile. I haven't checked Momoza's answer. Let me see. You have this one, you have a 25, and then you changed it, you have a 1, and then you switched them around, you ended up having that, you have 1/4. What you did is fine. So you know these things, guys. Ritabile is fine. You have Ritabile, you have Momoza. So I think we are fine with these decimals here. So there is no point to actually move forward. So you know how to deal with this. Even though I wanted to say this was 2,5, but the answer that you got is actually fine. I'm happy with it. I wanted to say this is 2.5. Yeah. So the answers that you actually got, they are all fine. Now I want us to talk about these nice things here before the time is up. I can also add here, just that I haven't compiled much questions. So how do you end up converting these decimals here? Remember that when we're dealing with numbers, we started with counting numbers, which is 1, 2, 3, 4, 5, 6, 7, 8. And then from there, after counting numbers, you started to add and subtract those numbers. When you are adding and subtracting those numbers, when you are adding, you are still getting a number that is positive. 1, 2, 3, 4, 5, 6, 7, 8, up to 10 and up to 100 sometimes. So those things were actually fine there. And those numbers, the counting numbers, we said that they are actually natural numbers. And then we moved from those numbers, we started to talk about when you're multiplying these natural numbers, you still get a number that is still within these positive numbers, and there is no decimal there. And then after you did that, what you ended up doing, you actually started to subtract these numbers. And you noticed that when you're subtracting, let's say 5 out of 2, you start to get a negative number because 2 is smaller than 5. And then we moved from those numbers, we talked about integers. Of course, what I'm saying here is just going to highlight some of the important things so that you can understand why I'm talking about this word, the rational numbers here. And then from those numbers, you found out that you needed to add some negative numbers. And then we started to talk about integers, negative integers, and also included what we call a 0. And then from there, when you are taking an integer, you are dividing with another integer. Sometimes you get a whole number, sometimes you end up not getting a whole number, a decimal point. So out of these decimal numbers, there are two sets that you can get out of them. The first one can actually be rational numbers or irrational numbers. So this conversion here will only be focusing on rational numbers. Of course, you have rational numbers and irrational numbers. When you're combining them, you end up getting the set of real numbers. So I just wanted to highlight that the definition of these things, they don't really matter. They are not going to be examined. I'm just trying to highlight some of these things so that you can understand that rational numbers and irrational numbers play a huge role when it comes to these decimals. And also for us, we will talk about more the rational numbers. Rational numbers are numbers that can be written in a fractional form with both numerator and denominator, such that the denominator is not equal to 0. That is simply the definition of rational numbers. But how do you spot a rational number? A rational number is a number such that if, let's say, you are writing it, it's going to be a decimal point, and then you have some numbers there, and there is no number after that. Maybe the numbers end here. Or a rational number is going to be a number such that after the comma, there is some repetition of numbers, even though they continue forever. So that's how you actually see them. So what I want you to actually become an expert at is to convert this. I want you to be able to convert this whole thing to a fraction whereby you have a numerator over a denominator. And also here, I want you to end up converting this to have a numerator over a denominator, and the same thing here, I want you to end up having a numerator over a denominator. That's what I'm expecting from you. These definitions, they don't really matter. I want you to be able to actually convert this, right? So as your homework, I want you to try and see how can you end up converting this to that, and also this one to that, and also this one to be in that form, and also this one here to that. Of course, if you want to, we can also add here, let's say 0,123, 123, 123, and then after that 123, and then we have these 3 dots to say that this sequence continues. Or we can just simply write this like this so that you can know. We have a bar there to say that I have 1, 2, 3, and then 1, 2, 3, 1, 2, 3, so forth. So I want you to convert these to fractions, convert these things to fractions, and then if you can do that, we'll be happy to move to other topics that are actually more important in what we will be actually doing in this course. Any questions so far? You can unmute yourself, and then you can say what are your problem, or what is your suggestion, or what you are thinking. Anyone with a question? Okay.
Uxolo ndimse ilaa ndawo yokugqibela leya indibhidayo mna kule besiyenzile sayisubmitha kuWhatsApp leya part yokugqibela, then enye le ndiyayiva sekuqaleni. Umzekelo phaya wa-cross multiplier ngo-10, then kwashiyeka 36/12, then ke phaa kwezaa ndawo ke kuze endaphe kuphuma u-3/1.
Oh, you are confused, ba? Okay. Maske siqale phansi le nto. Asiqale phansi, then uzoyibona, then ndingabikho fast. So what we said here is this. Let me open a nice room here. So from this one here, we said that we are actually having 3.6 and then divided by 1.2. So the first thing we said, we wanted to convert this one here to be wanted to convert it to a mixed number. So when we are converting it to a mixed number, you take this number, sibeke njengobenjalo, sithathe le siyenze numerator, and then after that siyazibuza uba zingaphi numbers ezisemveni kwale decimal point. If e1, you know that uba u0 uzoba i1 up, and then you are having it like that. And then you still have divide. Of course, masesifika apha sinalo 1, and then kwi-numerator sibe nala 2, and then kwi-denominator soba no 1. Bangapho 0, balingana ne-number ye-numbers, uba zingaphi ezi numbers lapha. Since kukhona 1, u0 uzoba i1. And then masesisuka ke ngokwapho sitshintsha lento siyise kwi-fraction. So umultiplier u3 ngo10, uthole bani u30, and then u-add u6 lower kwi-numerator, and then you're gonna divide by a 10, and then you still divide this whole thing ngale. 1 times 10 ngu-10, and then u-add u2 lower kwi-numerator, and then udivide ngabani ngo-10. And then xa sesisuka ke ngopha si-adda ezi numbers zoyi-2 sibe nala 36 sidivayidishe ngo-10, and then sisenabani sisenala divide. And then xa sesisuka ke ngokule sizawuadda u2 no10 sithole u12, and then sidivayidishe ngo-10. Masisuka ke ngokwesi step sitshintsha lento le ngu-divide. Xa sitshintsha lento ngu-divide siyenza umultiply. So le into asiyenzanga nto lo ise there, but siyayitshintsha le siyenze umultiply. So xa siyitshintsha umultiply le iyenyuka iza phezulu le itshona ezantsi. So sizoba nabani sibe no10 over 12. Uyayibona? Uyayi-understand uzofika apha ne?
Yes, and I understand nakwala izifika apha.
Okay.
Then qala problem xa sekusukela apha sasayo.
Okay. So into ebendiyithetha kule nto yileyo yoba if umzekelo uno-36 times 10, apha kwi-numerator uzoba no-36 times 10, right? And then kwi-denominator uzoba nabani? Uzoba no-10 times 12. Uyayibona musa apha?
Yes, sir.
Yes. U-36 times 10 uyalingana no-10 times 36. And then sinabani apha sino-10 times 12. Uyayibona musa?
Yes, sir, ndiyayibona.
Yeah, then lo 10 because kukhona u10 kwi-numerator uyakhanselana nalo 10 kwi-denominator. So and apha uno-36 over 12. and then ke ngokubuza uba bangapho 12 ku-36 by 3 and then bangapho 12 ku-12 uyi-1 and then ube nala 3. Uyayibona mos le manipulation ndiyenzileyo?
Yes, sendiyayiva ke ngoku sendiyayibona.
Okay. Even if le manipulation buyenze kwi-denominator buzothola i-answer yi-1. Omnye nenye question. Ukhona onenye question? Okay, I will assume that there is no other question, and in the absence of questions, I am going to say the class is dismissed. Thank you.